One of the most important things I think we took from learning field methods in a place like Cyprus, and I know this is sort of a cliche in geology, but when we really understand both the academic aspect of geology and are able to take that into the field and to decipher the past, you can really almost see the rock record as these individual pages in the book. They all tell a different story about a different depositional environment and different processes that happen, faulting, folding, and it's really the process of uplift that is the most important. And at every site we measured the height of outcrops above sea level, because as we found through our various field methods was that most, if not all, of the Cyprus was once in a shallow or even deep sea environment. And it's the deep sea environment that was perhaps the most interesting, because what happens in Cyprus is there's something that's a rare phenomenon called an ophiolite sequence. And what it is it's uplifted cenosphere material, which is the transition between the crust and the mantle. And this area was a bunch of divergent plate boundaries, so we see a lot of volcanism. And the thing about the volcanism here is that it's both surface and subsurface volcanism. So as we walk along the island and go to different outcrops further into the island, we see pillow basalts give way to gabbros and diorites and sheeted dikes, and which eventually give way to deeper and deeper rocks, particularly peridotite, which is an ultramafic rock that's really only found very deep areas in the earth. And it was really interesting to be able to see this geology and to use these new field methods that we had learned to be able to understand it. And interestingly, one of the things that we learned in the area was just how this geology sort of mixes with the human side of things, in terms of how successful, or in the case of Cyprus, how much it was exploited for its resources historically, and perhaps you could argue that it currently is as well. The Romans valued Cyprus for their copper, among other elements and minerals. The British Empire had an asbestos mine in Amianos, which we visited, which is really an interesting thing to see. And there's all these natural gas and oil operations off the shore now, and all of this is sort of made possible by this unique geology of the region. And it's really a special place. These outcrops are some of the premier geology sites in the world. But perhaps one of the most interesting places that we went to, and it's perhaps a bit of an underrated site, were some of the gypsum outcrops that we saw near shore. And perhaps there, more than anything else, we could see the geologic past manifest itself in the rock record, in that these gypsum outcrops are evaporites. And evaporites are what happens when seawater leaves an area and leaves behind dissolved minerals, which form into a rock. We have good examples of this underneath Detroit, where we have large deposits of rock salt. And by the same token, it was either the same day or a couple days after, we saw this sunken basilica, which had been built before sea levels had transgressed and put it underwater. As we learn about these sorts of things, and we use methods that we learn in the classroom and apply them to the real world, we can piece together the geologic past, and we can discover these kinds of things about regions. And we can see what this means for the human aspect of things. We can look at faulting and folding and tie it to seismicity, earthquakes, flooding, sea level rise, and all sorts of things that happen in the geologic past, and what it means for us as humans in the future.